In this example, we're going to investigate the difference between parallel and perpendicular lines. We're going to look at some specific examples to determine whether or not two lines are parallel, perpendicular, or neither. So before watching through this example video, make sure you know the definition of parallel and perpendicular lines. So speaking of that, what does it mean for lines to be parallel? This one's a pretty simple definition. The slopes are the same. Right? So parallel lines are most often recognized because they're two lines that when you graph them, they never ever intersect, right? And the only way that that's going to happen is if the slopes are the same. Now, for two lines to be perpendicular, those two lines have to have somewhat opposite slope. And here's what I mean by opposite. The slopes are the negative, so it's the opposite sign, reciprocal of each other. Okay. And what this looks like visually is that the two lines will cross, forming 90-degree angles. So the other option is neither, okay? For two lines to be neither parallel or perpendicular, that means they cross, just not at a 90-degree angle. So anything like this. Right, parallel, they have the exact same slope, and perpendicular means they cross at a beautiful 90-degree angle. And the way we can determine that, looking at equations, is by investigating the slope. So in this first example, part A, I'm going to compare this line with this line, and I want to determine if these lines are parallel, perpendicular, or neither. So what I'm going to do is convert these into slope-intercept form. That way the slope is a lot easier to see. So I'm going to subtract, on this first equation, subtract 2x from both sides, and divide both sides by 3. So over here I can see that the slope is -2/3. So now what I'm wondering is, what is the slope over here? So I'm going to do the same thing. I want to put this into slope-intercept form, which means I'm solving for y. So over here I'm going to divide both sides by -6. And the slope in this case is going to be -4/6. It's the coefficient on x. This fraction can be reduced as -2/3. And hey, look, they are the same, which means these two lines are parallel. Okay. Both slopes are negative, both slopes are 2/3. They exactly match, so these two lines are parallel. Okay, second example. X plus y equals 4, and x minus 2y equals 3. So I'm going to do the same thing I did before. I'm going to convert these into slope-intercept form just to make the slope easier to see. So over here I'm going to subtract x from both sides. So the slope is -1 right there. And over here I'll subtract x from both sides. And then divide both sides by -2. And so over here the slope is 1. half. So they do have opposite signs. One is negative and one is positive. But are they reciprocals of each other? And the answer is no. They're also not the same. So these two lines are neither parallel nor perpendicular, because it doesn't fit the definition. We didn't get the same slope, so they're not parallel, and these two slopes are not opposite reciprocals of each other, so they're not perpendicular. So these are just two lines that cross, just not at a 90-degree angle. Okay, last example, these two lines right here, 3x equals y plus 7 and x plus 3y equals 4. Same strategy. I'm going to put these into slope-intercept form to make the slope easier to see. So I'll subtract 7 from both sides. So over here, the slope is 3. And I'll subtract x from both sides and divide both sides by 3. So over here, the slope is -1/3. So these two slopes have opposite signs, positive and negative, and they're reciprocals of each other, 3 versus 1/3. So these two lines are perpendicular, because these are opposite, positive, negative, reciprocals, 3 1/3 of each other.